The three types of electrical loads, real life tests, no theory lies. The last time we talked about the three types of electrical load, we spoke about the resistive load, the inductive load, and the capacitive load. Today, we are not talking theory. We carried a power meter, we tested real appliances, and results are in. Let's go one by one. The first type of load, the resistive load, the honest ones. Resistive loads are the most truthful appliances in your house. What they say is what they do. LED bulbs, which is rated 10 watts, we measured it and it pulled about 10.6 watts to 11 watts. Steady, no drama, no surprise. LED bulbs are honest citizens. The electric iron rated 110 to 1300 watts. Now this one is interesting. When eating, it pulled about 1400 when set to the hottest level. But it doesn't stay on that forever because the thermostat it kicks in. You have your iron on for 30 seconds and off for about 15 seconds. So if we do the small math, you see that 30 seconds on, 15 seconds off. So the total cycle equals to 45 seconds. So the average power we are able to pull from this iron is 1400 watts times 30 divided by 45. So we're pulling on average 933 watts. Are you still confused? See a more detailed calculation in this video. So even though the iron consumes 1400 watts when it works, on average, it behaves better. The lesson we learn is resistive loads can be heavy but predictable. For the second types of load, the inductive load, the drama kings, the inductive loads are emotional. They don't start calmly. A fridge rated 80 watts, for instance, has a startup at 245 watts, and after settling, the power keeps moving between 100 watts and 130 watts. That's about 20 watts, a whole 20 watts deficit. Why? Because compressor kicks in, the motor, the mechanical movement. So the lesson we learned from this is fridge is not lying, it's just starting with energy. For the standing fan, the aux fan, which is rated for 150 watts, this one shocked us because from speed 1 to speed 3, almost same power. Sometimes the speed 1 even consumes more. Why? Because at low speed, motor struggles more. More struggles may mean more current draw, which equates to more power pull. So faster does not always mean more power. Fan do deceive people. We, if we don't even know this before, we now know now. So this further proves that inductive loads can be dicey. For the blender example, which is rated 120 watts, at full speed test, it pulls 178 watts steady. Why? Because the startup torque, the motor resistance, the blade load, and a whole lot of factors. This is why blenders can trip small inverters. You think that they are small, but they are quite pulling extra load. Now to the capacitive load, the calm and smart ones. These ones are very intelligent. They see power, not garbage. The TV, which is rated 70 watts, here's what we saw. At low brightness, it was pulling 14 watts. At medium brightness, 25 watts. So when we turn up the brightness to full and the sound to 100%, it was pulling 51 watts. That's so much for a TV that is rated 70 watts. So it means it never even reaches the 70 watts. Why? Maybe modern TVs use switching power supplies, capacitors, smart energy control. So the lesson we learned from these smart electronic devices are TV power depends on how you use it, not the label. Even the Mi Android box rated 5.2 volts and 2.5 amps. On paper, it should be consuming about 13 watts. In reality, it takes just 2.5 watts, even on full operation. Why? Efficient electronics, low processing demand, capacitive behavior. Because small device means small appetite, or let me say, may mean small appetite, especially for electronic loads. Now, for the big lessons we learned from this test. The first one, appliance ratings are not promises, they are just the maximum limit. Two, inductive loads start heavy, they calm down later. You may want to calculate your fridge, AC, freezer, and pumping machine with a times two or times three of its power as the starting up power, which is the surge power. Three, capacitive loads adjust based on usage. Four, power factor matters more than the label you have at the back of your electronic devices. Five, this is why systems fail when installers size by guesswork. Why this matters for solar? If you size solar like this, TV is 70 watts, fridge is 80 watts, fan is 150 watts, you will fail. But if you understand the startup surge, the average power consumption, the load behavior, your system will last. So the final line, electricity is not wicked, it's just misunderstood. Ensure you measure, understand, and design properly. Thanks for watching. Let me know if you have ever undersized any solar project before.